Hello, welcome to my channel. Today I am going to discuss about units and dimension analysis. Now, the basic system of units used throughout science and technology today is the internationally accepted system international SI units. Okay, SI units which have 7 base quantities. Seven. If we write them here, base quantity and their corresponding base unit is 1 length, unit is meter, m. Second base quantity is mass, base unit is kilogram, kg. Third base quantity is time, base unit is second. Now these three base quantities are now these three base quantities are used in mechanics, commonly used in mechanics. Mechanics is based on just the first three of these base quantities: length, mass and time. We can express the dimensions of some mechanical quantities, mechanical physical quantities such as velocity, acceleration, force, in terms of length, mass and time. Nothing others are required. Now, to express other physical quantities such as current, charge, inductance, capacitance, or other various quantities in electrostatics, magnetism, we further define four other base quantities, which are electric current, base unit is ampere, temperature, base unit is kelvin, K. 6, amount of substance, base unit is mole. 7, the final one, base quantity is luminous intensity. Unit is candela, CD, candela. As I said earlier, mechanics is based on just first three of these base quantities. Now the dimensions of these first three base quantities or let us write it on the next page. Is length length dimension of length is expressed as L. Dimension of mass is expressed as M, and the dimension of time is expressed as T. We express the dimension in third bracket always. Okay. The dimensions. Now let us find the dimension of various quantities. Now start with area. Area of anything. What is the dimension of area? Area. Now the unit of area of actually the dimension of area is a square. Now if we now look at the unit of area is for a square square of side A, the here area will be a square. This is length square, side it's length. Okay, for a circle area will be pi r square. Circle radius r pi r square. Pi is a constant, so in dimension length square will also just a square is taken. So the dimension of area in any case is a square. Now the dimension of volume is L cube. Similarly, if we find the volume of a say for a cube of side A, say for a cube of side A. Okay, it's horrible. Okay, this volume is a cube. For a sphere of radius r, say volume will be 3 pi r cube, 4 by 3 pi r cube. 4 by 3 pi r cube is a constant, so only r cube for only dimension will be for r cube only, so r cube is length, so the volume will be length L cube. Okay, now find the dimension of other quantities such as say frequency. say frequency. Okay, now what is the unit of frequency? Unit of frequency is hertz. Unit is hertz, which is second inverse. Now what is a frequency? Frequency is, say, amplitude for a wave. Say, for I'm just taking any wave arbitrarily. For any wave, the number of complete oscillations completed in unit time means the number of complete wave in unit time. Say this is 1 second, this is 1 second. Say now the number of complete wave here is, this is 1 and this is another one, that is 2. So here the number of complete wave is 2, so frequency will be 2 hertz, 2 second inverse. Now dimension of frequency is T inverse, time inverse 1 only. Well, this is page 2. Okay. Now find the dimension of other quantities, other derived quantities, other derived physical quantities such as velocity, Now what is velocity? Velocity is the distance traveled in unit time. So if we write the equation of velocity, it will be length per time. Distance is basically just length. So that if we write the dimension, length dimension is L and time dimension is T, so the final dimension is 18 inverse 1. If we look at the unit will be length unit is meter in SI system and time unit in SI system is second, so unit is meter per second or a meter second inverse 1. Now find the acceleration. Now acceleration is the rate of change of velocity. So if we write this equation only, it will be velocity per time. Now we know the dimension of velocity is 18 inverse 1 and the dimension of time is t, so the dimension of acceleration is Lt inverse 2 and its unit is velocity unit is meter second inverse 1 and time unit is second, so the final unit is meter second inverse 2, meter per second square. So this is meter per second square. Okay, now we are looking into the dimension of force. Okay, force. Now we just a popular expression P is equal to mf. force is equal to mass into acceleration. Mass into acceleration. Acceleration is velocity per time. If we express the dimension, it will be mass acceleration's dimension is mlt inverse 2. And final dimension is mlt inverse 2. And the unit is we can directly write the unit from the dimensions, or we can find the dimension from the unit. It is very easy. It is kg is for mass, and for the acceleration is meter second inverse 2 meter per second square, which we popularly known as Newton. Newton. Now let us find the dimension of kinetic energy. From mechanics, the popular expression of kinetic energy is half mv square, which is half is a constant. We can neglect it in the dimension and unit and dimension analysis. So it will be mass into velocity square. So its dimension will be mass m and velocity square is L square t inverse 2. Velocity is LT inverse 1. So square, if we take the square, it will be a square t inverse 2. So the final dimension is m a square t inverse 2. M a square t inverse 2. If we find the unit, its unit is kg meter square second inverse 2. kg meter square second inverse 2. Now it is popularly known as joule. kg meter square second inverse 2, which is popularly known as joule. Now this is page 3. Now let us find the dimension of other quantities such as work. Now work is, if we write the expression of work, it is force into length. Now the dimension of force, we already discussed the dimension of force. Dimension of force is mlt inverse 2 and the unit is Newton. Now mlt inverse 2 Write the dimension. ML T inverse 2, length is L. So the final dimension is ML square T inverse 2, which is the dimension of, as we previously see, which is the dimension of kinetic energy also. So the dimension of work done and kinetic energy is same. Unit is also kg meter square second inverse 2, which is joule J, same as kinetic energy. Okay, now let us find the dimension of power, which is the work done per unit time. Work, which is work per unit time. If we write the expression, it will be work per time. So the dimension of work is ms square t inverse 2, and the dimension of time is t. The final dimension is m square t inverse 3, and its unit is if we write the unit is kg meter square second inverse 3. You can just directly write the unit from dimension also, or find the dimension from the unit. It is very easy, which is popularly known as watt. Now, watt is also work. What is the unit of work? Work is joule per second. Now watt is also expressed as joule per second. This is page 4. Okay. Now let us find the dimension of some electrical quantities. Such as inductance, capacitance, resistance, etc. Voltage, current, etc. Okay. Say voltage. First find the current. Now what is a current? Now current is a base quantity, as we know from the System International SI units. Current is a base quantity, which is dimensionally expressed as A ampere. Now also current is charge flowing per unit time, rate of flow of charge, mathematically expressed as charge per time, Q by T. Or we can express the charge cube as current into time. So current dimension is A, and time dimension is T. So the dimension is 80. Unit of charge is coulomb, as we all know. Now find the dimension of voltage. V-O-L-T-A-G-E. Voltage. Voltage. Now voltage or potential difference. What is the potential difference? If we mathematically express this, it is energy available or work done per charge is cube. Now we already know energy, kinetic energy and work done. Energy and work done dimension is same, which is ma square t inverse 2. Let us write it here, square t inverse 2. And charge dimension is 80. Okay, the final dimension of voltage will be m is square t inverse 3 a inverse 1. M is square t inverse 3 a inverse 1, which is the dimension of voltage, and its unit is, we all know, unit is volt. Okay, now let us find the dimension of inductance, capacitance and resistance. First find the dimension of resistance. Voltage, charge, current, of resistance R. Now symbolically resistance we expressed as this symbol R. Now from Ohm's law, physical diode, Ohm's law, so resistance will be R is equal to V by I. Now we know the dimension of voltage. Dimension of voltage is this one, and the dimension of current is A, only A. Current, dimension of voltage M A square T inverse 3 A inverse 1, and current is A. So we write it here, M A square T inverse 3 A inverse 2. This is the dimension of resistance, and its unit is, resistance units is ohm. We all know that, ohm. Now further, if we find the dimension of inductance, inductance L, symbolically it is just a coil L. Now the voltage current relationship is we express the voltage in inductance as V is equal to L di dt, rate of change of current, or inductance is expressed as V is equal to di dt. Now we all know the dimension of voltage. We have to find the dimension of voltage dimension is, let me write it here, m a square t inverse 2 no, it's m a square t inverse 3 inverse 1. Okay, and the dimension of didt, it is change of current and change of time. Dimension is expressed as a and t something, it will be 80 inverse 1. So the dimension of inductance will be voltage m a square t inverse 3 inverse 1 and it is 80 inverse 1. Finally it will be m a square, this will be cancelled, and t inverse 2 a inverse 2, m a square t inverse 2 a inverse m a square t inverse 2 a inverse 2. Now the unit, now the unit of inductance is Henry. Unit is Henry H. Okay, this is page 6. Now I find the dimension of capacitance. Capacitance of capacitance. Okay, symbol of capacitor is like this. See, okay, now the expression of capacitance is C is equal to, capacitance is Q by V, charge or voltage. Okay, the dimension of charge, we previously discussed this. Charge is 80 and voltage, just write that here, and voltage is m a square t inverse 3 a inverse 1. Now final dimension of capacitance will be m inverse 1 l inverse 2 t to the power 4 a inverse 1. No, actually it's a square in a square. Okay, m inverse 1 l inverse 2 to the power 4 a square, so to the power 4 a square. Okay, it's okay, and its unit is Faraday. F. That's all for today, guys. Thanks for watching. Have a good day.